Lesson 7, Question 1. Simplify the following expression. 9x squared minus 10x plus 7 minus 8x minus 11x squared. So what we want to do here is combine the like terms, and like terms have to have the same variables with the same exponents. So I'm going to just rewrite it using the commutative property first. I'm going to bring the minus 11x squared over here with the x squared. I'm going to write the minus 10x and the minus 8x together, and then the plus 7. Now notice when I moved the terms around, I was careful to keep the sign with the term. Now I can combine. 9 minus 11 is negative 2x squared. Minus 10 minus 8 is minus 18x. And then plus 7 has no terms that it can be combined with. Now I have written this in what is called standard form, and that is where the exponents decrease in order. So you'll notice I've got an x squared followed by an x followed by a term with no variable. So number 1, the answer is negative 2x squared minus 18x plus 7. Question number 2. What are the leading coefficient and the degree of the polynomial? Well, the leading coefficient is the coefficient or the number in front when in standard form. So I'm going to rewrite this y to the 4th plus 2y squared minus 23y minus 4. And once again, as I rearranged the order of the terms, I was careful to keep the correct sign with the term. Now y to the 4th is in the front. It is the term that tells us our leading coefficient. It's going to be a 1 because there's an understood 1 to be in front of this y to the 4th term. Our degree is going to be 4 because the degree is the highest power in the polynomial, which if you have put it in standard form will also be the exponent of the first term. Number 3. Simplify. In parentheses, 7w squared minus 4w minus 2 plus, in parentheses, 3w squared minus 6w plus 1. Well, there are understood 1s to be in front of these parentheses, and that means that if I multiply 1 times these, I don't really need the parentheses. Now, if there's a minus 1 outside the parentheses, you have to be careful because you have to distribute that minus 1 throughout the parentheses and change all those signs in the parentheses. But because this is addition, I don't even need the parentheses, so I can just drop them off. Now I'm going to collect my like terms. 7w squared plus 3w squared minus 4w minus 6w minus 2 plus 1. Again, addition and subtraction, I can rearrange that if I'm careful and I keep the sign with the term. Combining the like terms, 10w squared, you don't add the exponents, you just add the coefficients, minus 10w minus 1. So I combine together the terms that are alike to get my final answer. 10w squared minus 10w minus 1. Number 4. Use the distributive property to remove the parentheses. 7a to the 5th times 4 minus 3a to the 4th in parentheses. Well, we're going to need our law of exponents here that say that when you multiply two bases that are alike, like x to the m times x to the n, you're going to add those exponents. So we have to remember that when we multiply, we're going to add. Now we have to distribute this 7a to the 5th times the first and the second term in the parentheses. So first I get 28 and then a to the 5th, because there are no other a terms inside the parentheses for that first term. Then it's minus 21, add your exponents, a to the 9th. Now this is not in standard form. I could rewrite this 21a to the 9th plus 28a to the 5th, and that would be in standard form because the exponents are decreasing in order. That's not required though, so if you want to leave it 28a to the 5th minus 21a to the 9th, that's fine. You can leave it that way. Question number 5. Multiply 3c plus 5 times 6c minus 1. Now some of you may have learned this by doing what is called the FOIL rule, F-O-I-L, where you multiply the first two, the outer two, the inner two, and the last two. But that is only going to work if you have a binomial times a binomial. So instead of the FOIL rule, let's use the distributive property twice on this. All I need to do, and let me just make a little graphic here that we can use to help us. All right. So here's what I'm going to do. I'm going to pretend there is no 5 here. It's just 3c times 6c minus 1. So I'm going to distribute the 3c times the 6c and the 3c times the minus 1. That does the F and the O of the FOIL rule, but it also shows you this is just the distributive property. So it's going to be 3c times 6c, 18c squared, and then 3c times minus 1 minus 3c. So distribute the 3c to both. Now I need to come back and ignore the 3c and distribute the positive 5 to both. So keep in mind you need a sign between these. So positive 5 is going to get distributed to 6c, and then positive 5 is going to get distributed to minus 1, and we're doing multiplication, so it's going to be plus 30c minus 5. So the first two, 18c squared, the outer two, minus 3c, the inner two, 30c, and the last two, minus 5. So I double distributed. The 3c got distributed times both, the plus 5 got distributed times both. Now I'm going to combine my like terms to get a final answer of 18c squared plus 27c subtract 5. That's my final answer. Number 6. Same kind of problem, just with more variables involved. So I'm going to distribute first the 3x. So it's like I'm ignoring this minus 2w. I've got to do a 3x times a 7x and a 3x times a minus w. So 3 times 7 is 21x squared. Then it's minus 3xw minus 14. Wx is the same as xw. And then plus, because it's a negative times a negative, 2w squared. I do have like terms. Okay, XW and XW are alike. And remember, XW and WX are also alike because you can multiply in either order and still have the same answer. But when I combine my like terms, it's 21x squared minus 17xw plus 2w squared. So these two terms in the middle, same sign, I added and kept the sign, and I got the minus 17xw. Number 7, multiply. U minus 6 times u plus 6. Well, this is also the double distributive. The u has to be multiplied times both. Then the minus 6 has to be multiplied times both. But a pattern is going to emerge here. Watch what happens. U squared plus 6u minus 6u minus 36. Well, positive 6 and minus 6 is going to give me 0, so it's u squared minus 36. So there is a shortcut name for this and a shortcut way to do it. This is called multiplying conjugates. And you need to know that word conjugate because we'll use it again in a later lesson. Conjugates. Multiplying conjugates. Conjugates are binomials that are almost the same. The terms are the same, but the signs are different. So they both have an A term and a B term, but one is addition and one is subtraction. Now, because of that, a squared minus ab plus ba, which is also ab, minus b squared, these inner terms will always add to 0. So it's a squared subtract b squared. So if I see conjugates, u minus 6 and u plus 6, and those can be in either order, but they have to have opposite signs, I know that the 6 and the minus 6 are going to reduce to 0. So u squared minus 36. I can just go straight to the answer. Now that's different from number 8. U minus 6 squared means we take u minus 6 times u minus 6. So this time, u squared minus 6u minus 6u plus 36. So this time they're not opposite signs, they're the same sign, so you end up doubling up your u terms. So in 6 and 6 is going to make 12. So the answer is u squared minus 12u plus 36. Now there's also a shortcut for this, and it's just binomial squared. And this can be done with plus a and b or a minus b. A squared plus double up a times b plus b squared. Or a squared minus double up a times b plus b squared. So in both cases, you square the first, you double up a and b, and then you square the last. If it's a plus, it's going to be all pluses. If it's a minus, the first term is going to be a minus. So if I see u minus 6 squared, I can say that's u squared, double up, negative 6 and u would be negative 12u, and then square negative 6 is 36. Another example, x plus 5 squared would be x squared, double up 5x, that's 10x, plus 25. Okay, let's do 2x minus 3 squared. Well, that's going to be 4x squared. That would be 6x, so double that, minus 12x, and then plus 9. So it's square the first, 2x times 2x, 4x squared. Multiply these two, negative 6x, but double it for negative 12, and then square the last one, plus 9. All right, so let's do number 9. It's very similar. 3w plus 5v squared. So because it's the shortcut, now if I need to write this out and use the full or the double distributive, that is okay. I would rather you write it out and get it right than to try to do a shortcut and get it wrong. But if I follow the pattern, I know that I square the first one, so 3 squared and w squared is 9w squared. It's a plus, so I need a plus. 3 times 5 is 15, but I've got to double that, 30wv. And then 5v squared is 5 squared, 25, and v squared. So if you do it this way, it's 9w squared plus 15, which is where the 30 comes from, and then 25v squared. So feel free to write it down twice and use distributive or full, or to use the pattern, which says square the first, double up the both of them together, and then square the last. Number 10. Here's why you don't want to always rely on the full rule. 7v plus 5, 2v squared plus 3v minus 6. Here, I'm going to use my method where I ignore part of it. So I'm going to ignore this plus 5. I'll just pretend it's not there. And I'll do 7v times all three of these. That's distributing the 7v. Now when that's done, I'm going to cover up or ignore this, and I'm going to do the 5 through. And then I'll combine my like terms. 7v times all of them, 14v to the third, 21v squared, minus 42v. So that was 7 times all 3 in the second polynomial. Now watch what I do, because I'm going to combine like terms eventually. When I come back and multiply, I'm going to write them where they need to be. Plus 10v squared plus 15v minus 30. So I've lined up my like terms. It makes it easy. 14v to the third plus 31v squared minus 27v minus 30. And of course, I can use my calculator to do negative 42 plus 15 if I need to. And it's better to use the calculator if you're not 100% sure. So once again, 7v times all three, then 5 times all three. If you line it up like this, it makes it easy to combine at the end. Number 11. Divide 6x to the 6th minus 24x to the 4th by 3x to the 3rd. So be careful here. The thing you have to recognize is that the 3x cubed belongs to both terms in the numerator. So the first thing you want to do is you want to split these terms apart and rewrite them both with the denominator 3x cubed. Then we're going to reduce the coefficients just like they're fractions or whole numbers, and we're going to use the law of exponents that says when you divide, you subtract those exponents. X to the m divided by x to the n is x to the m minus n. So for the first one, 3 goes into 6 2 times. 6 minus 3 gives me 3. And in the second one, 3 goes into 24 8 times. 4 minus 3 leaves 1. And of course, I don't have to write that exponent of 1, I can just write minus 8x. So my final answer is 2x to the third minus 8x. When we have one like number 12, we have to use long division. So we have 5x squared plus 18x plus 10 divided by x plus 3. So notice how I have written this in the long division format. If the divisor or the denominator has more than one term, like x is one term and 3 is another, then you can't use that method where we split it apart. What we're going to do here is we're going to, at first, just at first, we're going to ignore the plus 3. So it's like the plus 3 is not there. And we're going to divide x into the first term. Well, remember how division works. Let's just look at a couple, or let's just look at one with numbers. Let's say I want to divide 3 into 5, 1, 8, 1, 0. I just took the numbers off here. Okay, not going to be the same problem, but you'll get the idea. I'm going to divide this 3 into this 5 first, and it's going to go one time. And 1 times 3 is 3, and I'm going to write it underneath here, and then I'm going to subtract. So after I subtract, I'm going to bring down, and if you want to bring down the whole thing, you can bring down the whole thing, or you can bring down one digit at a time. Then I'm going to repeat the process. 3 into 21 is 7. 7 times 3 is 21. Bring down, that's going to be a 0, so bring down the 810. 3 goes into 8 2 times. 2 times 3 is 6. 2, 1, 0. Three goes into 21 7 times. 21. Bring down the 0. Now, because there's an extra 0 here, this 0, it's going to end up in my answer up here. And you can check that on the calculator, and you can see how that divides 3 into 51, 8, 10. But remember what we did. We did divide, then we did multiply, then we did subtract, then we bring down at least one term or one digit, and then we repeat. So it's divide, multiply, subtract, bring down, repeat. And we're going to follow those steps as we do this problem. So, like I said, we're going to ignore this 3 and we're just going to divide. I need a 5x here. Why? Because 5x times x is 5x squared. So I want that first one to match so that when I subtract it, I get 0. Now I have to also bring this 3 into consideration. 5x times 3 is 15x. Okay? But I also have to subtract the 15x. So I'm going to change the sign of that 15x here, just like I changed this to minus here. So I do 18 minus 15 is 3x, and then I bring down the plus 10. And I have to divide again. So now I'm to the repeat. Look, I divided and got 5x. I multiplied and got 5x squared. I subtracted by making both of these minus, okay, change the sign of both of those. Then I brought down, I subtracted here, and I brought down the 10, and now I'm repeating. So x goes into 3x plus 3 times. And I have to multiply 3 times x. Look, I'm doing this 3 times both of these. 3x and 3 times 3 is 9. Then I've got to change the signs, change a sign, and I get a 1 here. And x won't go into 1, so that's my remainder. We call that the remainder. Now the one I did a few minutes ago with numbers didn't have a remainder. The remainder was 0, so we didn't have to worry about that. So in ALEKS we would say that the answer is this top part, 5x plus 3, remainder 1, if they ask it that way, or you can also write it 5x plus 3 plus 1 over x plus 3. So you write the remainder over the divisor, just like you would if it was a fraction and you were just doing numbers. You would just write the remainder over the divisor. So either one of these answers is acceptable, and you'll just have to follow the format that ALEKS gives you. All right, one more, number 13, the same type. Long division. I'm going to divide 2x plus 3 into 4x cubed plus 12x squared plus 11x plus 11. Start by ignoring the 3 and just going with the 2x. Well, to get a 4x cubed here, which is what I have to have, I need a 2 times a 2. I need an x squared times the x. That's my 4x cubed. Then I have to remember it also gets multiplied times this 3. So that's going to be a plus 6x squared. Now I've got to subtract both of these, so look, I'm going to change their signs. And then I'm going to bring down what's left here, 6x squared, and I'm going to go ahead and bring down 11x and plus 11. It's not necessary to bring it down yet, or to bring them all down, but I just like to keep up with all of it so that I don't forget it. Now I've got to go again. 2 into 6 goes 3. X, to get an x squared, I need another x. So I'm multiplying again. This time I've got to multiply this 3x times both of these. Okay? So 3x times 2x is going to be 6x squared. Remember, these first two have to match. Then I have to go back, and 3x times 3 is plus 9x. I'm going to subtract them both by changing the signs. 2x plus 11. Then I'm going to divide 2x goes into 2x one time. 1 times 2x is 2x. 1 times 3 is 3. Subtract, and I don't think you can see it there. My remainder is 8. So my answer is 2x squared plus 3x plus 1, remainder 8, or plus 8 over 2x plus 3. Either way is fine.